Okay, let me give you some more practice. So given this random distance time graph, work out, well, tell me when did the object start moving? So just by looking at this, you can actually answer that question. So remember, when someone gives you a graph inside your mind, try to visualize those three graphs. You've got acceleration time, and you've got speed time, and you've got distance time. Remember, the gradient of this graph represents the speed. The gradient of this graph represents acceleration, and the area underneath this speed time, this graph here, the area underneath this graph here represents the distance traveled. So we have been given this graph to work with. So inside your mind, you should concentrate on the third one down, the third graph down. Okay, so we are working with this one here. Okay, so now that you know inside your mind you're working with third graph down, try to visualize what's going on here. So imagine you sitting in the car with your dad. This here is a start. Okay, start. And then try and understand what's going on here. So remember, if you cover the distance of, let's say, 7, then it means that you and your dad sitting in the car would have moved up 7. Okay. Well anyway, try and visualize what's going on here. Well, answer the question: when did the object start moving? So try and look at this and try and understand what's going on. So answer the question: when did the object start moving? So press pause and have a go. So here, try to visualize this. So you sitting in a car with your dad. This would be the start. So this here is a distance of 0. Okay. Now you see at time, this is time going along here. At time equals 0, that means that the start of time, if that makes sense, you are already 2 meters away. So remember, when I say start here, this is not, we are not talking about the time. So what's really going on here is you can imagine it as like this. Let's say the post office is here. So this is the start. This is the post office. And at the start of time, which means when time equals 0, you are already 2 meters away from the post office. So the post office is here. 1, 2. So you and your dad sitting in the car would be somewhere here. Okay. So when time equals 0, there are in a way 2 starts here. This is the start of time, and this is our reference point. So our start of time, we are 2 meters away from our reference point. In this case, we are talking about the post office. So at time equals 0, you are 2 meters away from something. Okay. So 0, 1, 2, you are 2 meters away already. Now time equals 2, you are still 2 meters away. You are still here at time equals 2. Now at time equals 3, at time equals 2, you are still 2 meters away. At time equals 3, you are still 2 meters away. And when time gets to 5, you are 6 meters away. So because we are looking at the distance time graph, that's why you always have to zoom into what's going on here. We are talking about distance. So at time equals 5, you are 6 meters away. So this is 0, 1, 2, 3, 4, 5, 6. So now remember, we are now talking about distance. Okay. You are 6 meters away. So hang on. You're 6 meters away after 5 seconds. Okay, so after 5 seconds, you and your dad sitting in a car. I know it sounds weird sitting in a car, but you're only 6 meters away. But just imagine it like that. So here, and then look what's going on here. At 9 seconds, so that's 1, 2, 3, 4 seconds later, you are at 7. You are at 7. So this is 7 meters away, and 4 seconds. So you are here. 4 seconds later, 1, 2, 3, 4. You are now here. Okay, and then here, 10 seconds, you are still at 7. So you are still at 7. 11 seconds, you are still at 7. at, at 12 seconds, you're still here at 7. And then look what's going on here. At 14 seconds, you are back at 1. Look at this. You are back at 1. At 14 seconds, you jumped back to here. So you traveled from here to here. Okay. Well, anyway, that's roughly what's going on. So to answer the question, when did the object start moving? Well, it started moving at 3 because remember our post office is here, which is at a distance of 0, but we started at 1, 2. We started here. Okay, so after 1 second, you are still 2 meters away from the post office. After 2 seconds, you are still 2 meters away from the post office. After 3 seconds, you are still at 3 seconds you started moving. Just after 3 seconds you started moving. So you started moving at when t equals 3, when time equals 3 seconds. Well, 3 seconds after. Okay, that's when you started moving. Now, looking at this distance time graph again, answer this one. How far has the object traveled after 9 seconds? So the question 2 here. How far has the object traveled after 9 seconds? So just by looking at this, how far has the object traveled after 9 seconds at time equals 9? Okay, at time equals 9, how far has the object traveled? So press pause and have a go. Okay, so look what's going on here. The post office is here. You started at 2. So at 9 seconds, you are at location 7. So 1, 2, 3, 4, 5, 6, 7. You are at location 7 after 9 seconds. Well, the distance traveled would be here. Would be this line here. So that would be 1, 2, 3, 4, 5. So the distance traveled would be 5 meters because you are here. This is distance here. Well, the distance traveled is 7 take away 2. Okay, it's this distance here. Okay. Question 3 is what is the speed of the object at t equals 4? At 4 seconds, at 4 seconds here, what is that speed there? So press pause and have a go. And remember, inside your mind, you've got the acceleration time graph, you've got the speed time graph, you've got the distance time graph. We have been given this to work with, and remember, the gradient of this represents the speed. So here to answer question 3, what is the speed at time equals 4? Is what is the gradient of this line here? So I'm going to use this triangle here. Okay, you could use this triangle here, but for some reason I prefer this. Okay, so the gradient, I'm going to use this triangle here to work out the gradient. So the height here would be 4. The across here would be 2. So 4 divided by 2 will give you the gradient. 4 over 2 equals 2. So the speed is 2 meters per second. Okay. So the answer to question 3 is 2 meters per second. Okay. Now what is the fourth question? What is the speed when time equals 13? So hang on, let me clear this up. Time equals 13 is here. What is the speed at this point here? Think about what's going on. So imagine the post office. You started here. Imagine what's going on here. Well, I want to know what is the speed at this point here. Press pause and have a go. Okay, again the speed is really the gradient of this, because what's going on here is that, well, at time equals 12, the object is 7 meters away. So 0 here, 1, 2, 3, 4, 5, 6, 7. 7. So the object is at 7 when time equals 12. Okay. 2 seconds later, the object is at 1. So now the 2 seconds later, the object has, well, in a way you're traveling backwards. So from here to here, you're traveling from left to right. But from this moment on, from here to here, you are traveling in the opposite direction. You are traveling from right to left. But don't forget that there's still a speed. Okay. Well, the speed is, again, the speed is the gradient of this thing here. So I'm just going to use this triangle here. The height here would be 6. The across here would be 2. So 6 divided by 2 would be 3. So the speed would be 3 meters per second. You see, speed is not a very well. When we talk about speed, we inside our mind, for some reason, we tend to always think it's going from left to right. We are always thinking this direction. But when you say, "Oh, I'm going at a speed of 3 meters per second," inside your mind, you're actually thinking you are still going to the right. But in fact, you are actually going to the left. But the speed is still 3 meters per second. You see, a better word to use would be velocity. Velocity. You can just say, "Oh, the velocity is minus 3, well, negative 3 meters per second." You see, but by you saying minus 3 meters per second, people will immediately know that you are traveling backwards. Whereas if you say 3 meters per second here, yes, you are traveling in this direction, but inside other people's minds, they're thinking you're still going in this direction. So speed in this case is not a very good word. Velocity is better, but you can't say, "Oh, you're going at a speed of minus 3 meters per second." It doesn't make sense to have a speed of a negative speed. It just doesn't make sense. But you can have a velocity of minus 3 meters per second. Well, don't worry about this velocity thing. I will make more videos on velocity. But for the time being, well, to answer the question, the speed is 3 meters per second. Okay.